Hello everyone, today we are going to talk about concept of vapor pressure and relative humidity. First we'll discuss what is vapor pressure. So we'll write the definition. So vapor pressure is the pressure exerted by the vapors of liquid in thermodynamic equilibrium with condensed phases in a closed system. So this is the simple definition and you can read all this to understand about vapor pressure better. So basically the vapor pressure of liquid can be measured in various ways. The simplest way to measure vapor pressure is using a manometer in a closed container or a flask. We'll use it and we'll determine the vapor pressure. So let's do it. So we have drawn a manometer here and it consists water in liquid state. Also the temperature is kept constant here and this container is basically enclosed, and the process of evaporation as well as condensation will be taking place here. So the liquid will be get evaporated and these vapors collected here, since the container is closed, they will get condensated. So process of condensation will also takes place here. Also the height of this liquid, let's call it h. So initially the rate of evaporation is more than the rate of condensation, right? Because only water is present in liquid state there. As more and more number of particles evaporate, the rate of condensation starts increasing slowly, right? And after a certain time a state of equilibrium is attained, at which the rate of evaporation becomes equal to rate of condensation. The pressure exerted by vapors in this equilibrium state is called the vapor pressure. So when the rate of evaporation is equal to rate of condensation, the pressure exerted by the vapors is known as vapor pressure. So basically this takes place at equilibrium condition. Now we'll write a note. This is very important. The value of vapor pressure of liquid depends only on temperature and it doesn't depend upon volume of vessel or amount of liquid taken. Now we'll draw a graph of rate versus time. So here rate of evaporation as well as rate of condensation graphs are drawn and equilibrium state is mentioned. So rate of evaporation will be equal to rate of condensation at equilibrium. You need to remember this graph. It's very simple to draw, right? Now we'll move further and solve a problem. So here a container contains O2 gas and some amount of liquid water at a total pressure Pt of 325 mm of mercury. Given that the vapor pressure of water is 25 mm of mercury, case first, if the volume of vessel is doubled at constant temperature, find out the new total pressure. Case second, if the volume of container is halved at constant temperature, find out the new value of total pressure. So let's solve these two questions by keeping in mind that the value of vapor pressure depends only upon temperature, and since the temperature is kept constant in both the cases, so the value of vapor pressure of water will remain the same in both the cases. Now we'll draw a container and over here we have liquid water and as well as O2 gas. So this water which is in liquid state, and inside this container we also have O2 gas, right, and water in gaseous state as well, which will give us the vapor pressure, right? Since it's the pressure exerted by water at equilibrium state, we know that total pressure here is 325 mm of Hg, which is given, and vapor pressure of water here is 25 mm of Hg. Vapor pressure will remain constant in both the cases. Why? Because we have written a note earlier that vapor pressure depends only upon temperature. Now to solve this problem, we will first determine the partial pressure of oxygen. So to determine it, we'll write that partial pressure of oxygen will be equivalent to total pressure minus vapor pressure of water. It will come out to be 325 minus 25. It will be 300 millimeters of mercury. So we got the partial pressure of oxygen. Only this will change when we change the volume, right? And the vapor pressure will remain same because volume is changed but temperature is kept constant. So now we'll solve the first part, where we are given that volume of the vessel is doubled at constant temperature. Find out new total pressure, right? So volume is being doubled, the temperature is being kept constant. We have to find the new value of total pressure, Pt, we have to determine. So in order to determine it, we'll write the ideal gas equation. PV is equal to nRT. Temperature is kept constant, so pressure should be inversely proportional to volume. Since volume is doubled, so pressure will be halved. So whose pressure will be halved? Only the partial pressure of oxygen will be halved. So here we'll draw the container. So it consists water in liquid state as well as oxygen that is in gaseous state. Here we'll write the vapor pressure of water, which is 25 mm of Hg. It will remain unchanged. Why? Because temperature is kept constant. So now we'll determine the new partial pressure of oxygen here. So we'll write that new pressure of O2 gas will be equivalent to half of that of original one, which was 300. So it will come out to be 150 mm of Hg, right? So we can clearly determine the total pressure here. So PT, whose formula is vapor pressure of water plus new pressure of oxygen. So new total pressure will be equivalent to 150 plus 25, right? So it will come out to be 175 mm of Hg. So this will be the answer of our first part. When volume is doubled, the new total pressure will be 175 mm of Hg. Now moving further, we'll solve the second part. If volume of container is halved at constant temperature, then find out new value of total pressure. So now the volume is being halved. What will be the new total pressure? So we know that P is inversely proportional to V. So volume is being halved, so pressure will be doubled, right? Only the partial pressure of oxygen will change. Here we'll draw again water in liquid state and oxygen which is in gaseous state. The vapor pressure of water will be same, which is 25 mm of Hg, which was given in the problem, right? And we'll determine the new value of partial pressure of oxygen, which will be 2 times of original value. It will come out to be 600 mm of Hg, right? Now we can clearly write the new value of total pressure. It will be new partial pressure of oxygen plus vapor pressure of water. So 25 plus 600, it will come out to be 625 mm of Hg. So simply this will be the answer. When volume is being halved, the new total pressure will be 625 mm of Hg. So this is the answer of second part. Hope you understand this. Now we'll move further and talk about relative humidity. So what's relative humidity? We'll simply write the formula here. So percentage of relative humidity can be written as partial pressure of water in gaseous state divided by vapor pressure of water multiplied by 100. So this is the simple formula. Partial pressure of water in gaseous state divided by vapor pressure of water multiplied by 100. We'll write example here. At 25 degrees Celsius, vapor pressure of water is given as 25 mm of mercury, right? And for case 1, let's take partial pressure of water in gaseous state is equal to 20 mm of Hg. So we'll talk about relative humidity here. So we'll simply apply the formula. So it will be 20 divided by 25 multiplied by 100. It will come out to be 80%, right? So since it's less than 100%, so we'll call it as unsaturated vapors. Just simply remember the formula for relative humidity. You can simply solve these numericals. This can be asked in JEE Mains as well as in NEET problems. Case 2. Let's say that partial pressure of water in gaseous state is 25 millimeters of mercury. In this case, the percentage of relative humidity can be written as 25 divided by 25, which is partial pressure of water in gaseous state divided by vapor pressure of water. So it will come out to be 100%. So we can call this as saturated vapors, right? Since the percentage of relative humidity is 100%. And now we'll write the third case where relative humidity will be greater than 100%. So let's say here we have the partial pressure of water given as 30 mm of mercury. So percentage of relative humidity will be equal to 30 divided by 25 multiplied by 100. It will come out to be 120%, right? Multiplied by 100, it will be 120%. So since it's greater than 100%, we'll call it supersaturated vapors. So when relative humidity is less than 100%, it's unsaturated. When relative humidity is 100%, it's saturated. When relative humidity is greater than 100%, it's called as supersaturated, right? So simply this is all about relative humidity.